Hey YouTube, and welcome back for another day of the 75-day Blind 75 challenge, where we're going to solve one coding problem per day from the well-known Blind 75 list. Today we have a deceptively simple question. It's number 217 and it's called Contains Duplicate. The question is as follows. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. From the examples, we are given the array nums, and we return true because we can see that the number 1 appears at least twice. And example 2, we can see 1, 2, 3, 4, and we return false because these are all distinct numbers. So let's get started. So let's think about how we can keep track of the values that we've already seen when iterating through our array. Well, we can use a data structure called a hash set. A hash set allows us to store particular data types and will only allow us to store a certain value once. So what we can do is take a look at our hash set and check to see if the value at the current index is already present. If it is, that means we've found a duplicate. So let's get started with the implementation. First, we want to define our hash set. And next we just want to iterate through our array. So we're going to do for int I equals 0, while of course I is less than nums.length. And let's increment I. Okay, next we just want to see if values contains the value at nums of I and return true if it does. Else, we're just going to store the value at the current index into values. And then finally, we're going to return false if we've gone through the array and we haven't found any duplicates. And let's run that. Okay, great. So the runtime complexity of this one is big O of n, which we know is pretty fast, and I'd say we're done. Or are we? Well, a common curveball that an interviewer might throw out is, what if we can't use a hash set? And what they're really saying is, what if we want the space complexity to remain at big O of 1? So we have to think of another way to check if there's any duplicates. Well, wouldn't it make life simple if we can simply sort the array before we start iterating through it? That way we can check the value at the current index against the value right before it. If they are the same value as each other, we know that we've found a duplicate. So let's call arrays.sort on nums, which will sort our nums array. Next, we want to set I to 1, and then we want to check if nums at I is equal to nums at I negative 1. And this means we found a duplicate, so we'll just return true. And let's run that one more time. So how does this change our time and space complexity? Well, to answer that, we have to know the time and space complexity of arrays.sort. So looking at the algorithm behind the sort method, I can tell you that it uses a dual pivot variation of quicksort, which for primitive data types, such as ints, it has a space complexity of big O of log of n. So we've definitely improved the space complexity. However, it also has a time complexity of big O of n log n. So this does drastically decrease the performance of our algorithm. These are things that you will be expected to explain so that you can weigh pros and cons of using certain algorithms. And with that, that ends another day of the 75-day challenge. If you enjoyed this video, please click like and hit that subscribe button, and I'll see you tomorrow for another question.